This video is about ion formation, electron configuration for ions, and naming of ions. It goes along with your electron configurations for ions notebook task, so make sure you have that handy as you go through this video. First thing we need to discuss is what are ions and how does an atom become an ion. An atom is usually neutrally charged because the number of protons equals the number of electrons. But in ions, this is not the case. In ions, they'll have either a positive or negative charge because the number of electrons has changed. Now, why does the number of electrons change is the question. We're going to take a look at a couple of elements to see what's happening here. The first element we're going to look at is chlorine. And when you did the electron configuration for chlorine, you got this. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Now remember, the big numbers, like 3 and 3, refer to the energy level. So in the third energy level, there are 2 plus 5 electrons, or a total of 7 electrons in the third energy level. Now, atoms are finicky, and they prefer to have a full energy level. And in this case, a full third energy level equals 8 electrons. So what this atom would really prefer to have, what it wants to have to be stable, is 8 electrons. Now, how is it going to get 8 electrons? Well, if it can find another atom that's willing to give up an electron, so 1 electron to add to those 7, then it will have 8 electrons. And that p orbital in that third level will be full. It'll be a p6. But remember, electrons have a negative charge. So if it does get that extra electron, it's not going to be a neutral charged chlorine atom anymore. Instead, it's going to be a chlorine atom with an extra electron. So it would be a negative charge. So that's how chlorine becomes an ion. Now let's take a look at sodium. When we look at the electron configuration for sodium, sodium is 1s2, 2s2, 2p6, 3s1. So again, take a look at that third energy level, that outer energy level. There's the 3, and there is only 1 electron in that third energy level. Now, to make that third energy level full again, remember we'd need 7 more electrons. Well, that's a lot of work. It's a hard thing to get 7 electrons donated if you're a sodium atom. But it is pretty easy to give up your 1 electron here to another atom, and then you'd be down to just your second level atom, or second level electrons. Okay, so the level 2 electrons are here. Level 2 has 2 from the S and 6 from the P for a total of 8 electrons. And then sodium would be happy. So it wants to get rid of that 1 electron. So if it gives away that 1 electron, it's going to have a stable outer level, so it'll have that second level, energy level, full of 8 electrons. And it's going to, because it got rid of its extra electron, so it lost a negative charge, that means it's going to be positively charged because it has 1 less electron. Now, again, it needs an atom that's willing to take that electron, and we just discussed that up here. Chlorine is willing to take an extra electron to be stable. Sodium wants to give away an extra electron to be stable. So what we end up having eventually, and we'll talk more about this later, but sodium and chlorine like to get together to form sodium chloride, or table salt. But what we're mostly concerned about here is how these ions are formed. So again, the whole idea is to look at the energy level, the outermost energy level, and see what's easiest for it to do. Is it easiest to gain electrons or lose electrons to get to a full outer energy level? All right, with that, we're going to start looking at your notebook task. So the first question on your notebook task asks, describe what happens when an atom becomes an ion. And that's what we just went over. So you need to rewrite in your own words a summary of how an atom becomes an ion, whether a positive ion or a negative ion, and give both examples. So you may want to pause the video to work on that. For number 2 in the notebook task, it asks you to write electron configurations for the ions of the following elements. Don't use the noble gas configuration, write the full electron configuration. So we're going to do the first 2 together as an example, just so that it can get you started. And I know that these didn't come across very well, so we're going to ignore these. And I will just rewrite them. Your first example is lithium. Okay, so let's do the electron configuration for lithium. Lithium is element number 3. So we're going to start with 1s2 and 2s1. There are 3 electrons. 2 plus 3 is our 3 electrons. Now, let's make it into the ion, because remember we're writing the ions for the following element. So if lithium has in its outer orbital, in its outer electron level or energy level, so in its outer energy level, it only has 1 electron, and it would like to have a full outer level. In order for 2 to be full, we would need to take on a lot more electrons. So it's easiest for lithium just to give up that electron instead. So what we're going to do is we're just going to cross off that last level, showing that lithium gave up its last electron, and rewrite lithium's ion electron configuration as 1s2. Okay, it lost the electron from its outermost energy level. Okay, so then let's look at the second one, letter B. Letter B is boron. Now boron would normally be written as 1s2, 2s2, 2p1. Okay, boron has 5 electrons, 2, 2, 5. However, we need to look at that outer energy level again. We're looking at all of the 2's for the energy level, and right now we have a total of 3 electrons in that outer energy level, 2 in the S and 1 in the P. Okay, in order to be stable, it could do one of two things. It could take on more electrons. In this case, it would need to take 4 more electrons. We're at 3. It would need to take 5 more electrons to be stable, right? Because the 2 and the S, right here again, and the 1 in the P is 3. It would take 5 more to get to 8 in other words to have a full outer energy level. Or it could lose these 3, these 2 and this 1 in the second energy level to become stable. And that's what it does. Okay, it's easier to lose 3 than it is to gain 5. So we lose that whole energy level of electrons. All the electrons in that energy level go away. And so boron, once again, what's left over? Boron is going to equal 1s2. So the ion configuration for both of these is actually the same because they both end up losing all of their electrons in their second energy level. So at this point you can pause the video and go ahead and do the rest of the samples. So you've got C through J left to do on your sheet. The next section in your notebook task is the chemical symbols for ions. So for each symbol you're going to give the element name, the number of protons, the number of neutrons, and the number of electrons. And again, this didn't come across in my copy of this, so I'm just going to write the first one. So we've got this configuration, okay, is what is written on your paper. So first of all, we need the element name. Al stands for aluminum. Okay, just a little test of your symbols. The number of protons, remember, comes from the atomic number, which is this one down here. So protons are 13. The number of neutrons is the atomic mass, which is up here, minus the atomic number, so minus 13. So 27 minus 13 tells us how many neutrons are left over, because it's the neutrons and the protons that give us the mass. So the neutrons are 14, because 13 plus 14 is 27. And now the number of electrons, and this should be the new part. Everything else is review up to this point. So remember, electrons are usually equal to the protons in a neutral atom. So we would normally expect that we have 13, right here, 13 electrons to balance out those protons. However, this atom has a +3 charge, which means it has lost 3 electrons. It became more positive because it lost those negative electrons. So if it lost 3 electrons, that means it is at in total of 10 electrons. Instead of having 13 to be neutral, it's lost 3 to have 10. So at this point, again, you can pause the video and go ahead and fill out B and C on your paper as well. Okay, now we're on to the next section here. It says, write the chemical symbols for the ions formed in questions 2A through J. Mine is kind of messed up again, so we'll ignore that. All right, and I will just do the first few with you here. We're going to start with letter A, lithium. Okay, so when we look at lithium up above, okay, we had lithium lost an electron. Okay, so I just want to point out where that is again here. How we know it lost an electron. Okay, if we look up here again at the top, right here, it lost 1 electron from its second energy level. So losing an electron makes lithium more positive because electrons are negatively charged. So let's go back down and write that for our lithium ion. So for our lithium ion, losing an electron gives it a +1 charge. Okay. It still has an atomic number of 3, and it still has an atomic mass of 7. Those do not change. Remember, you get those off the periodic table. The one thing that is different is that +1 charge, because the lithium lost that 1 electron. Okay, now we're going to look at the second one, which is boron, the one we did together. If you go back up to the first part, and we look at boron again, boron lost a lot of electrons, well, more electrons anyway, from its second energy level. So again, we're right here. Okay, it lost 2 electrons here and 1 electron here. So since it lost electrons once again, that's going to be a positive number for boron. And because it lost 3 electrons, it's going to be a +3. So boron +3. Again, the atomic number and the atomic mass you can find on the periodic table and do that on your own. Okay, you can go ahead and finish the rest, C through J again. Just remember the rule that if it loses electrons, it's going to be a positive ion. If it gains electrons, it's going to be a negative ion. So keep that in the back of your mind as you're doing these superscripts of positives and negatives. Pause the video and then we'll finish up the last section when you're done. Okay, for section 4 here, naming ions, pretty much explains for you how to do this, but I'm going to read through to make sure that you don't have any confusion here. It says a cation, for letter A, is an ion with a positive charge. When naming cations, the element's name is followed by the word ion. An anion, in letter B, is an ion with a negative charge. When naming anions, add an "ide" suffix to the end of the element's name, followed by the word ion. C. Now apply the naming rules to the ions formed in task 3A and 3B. Identify each ion as either a cation or an anion, then write the correct name for each. So let's go up to 3A and take a look at what that is. So 3A is this section up here. Our first one was aluminum that we made into an ion. Okay, I just want to highlight for you where this is. Okay, right here, this aluminum ion. So aluminum is a positive ion or a cation. And it says for a cation again, we name it with the element's name followed by the word ion. So for aluminum, we're going to write aluminum ion. That's the name of it. If you want to list them all below here, like I am, that's fine. Otherwise, if you want to go back to that section, so go right back to 3A and put the name aluminum ion by that ion, that would be great. You're also supposed to do 3B, so let's do the ones we did together as an example for 3B. They're both cations again. The first one is this lithium, and the second one is boron. So we're going to scroll down, and I'll write those for you. Again, because they are cations, we're just going to write the name, lithium, and then ion, and boron, and then ion. All right, and then don't forget, if it's an anion, if it's a negative ion, it's going to have a different way of naming. So you have to put an "ide" at the end, followed by the word ion. This isn't one of your examples until later, but chlorine was an ion you made in part B. So the naming for that as an anion is going to be chloride. There's that IDE, ion. Again, go through and next to all of the ions that you made in 3A and 3B, list their names.